Hello, this is Dr. Yam. We are going to see hotspot analysis. So today we are going to do hotspot analysis. So first of all, hotspot is like you may familiar with the terminology hotspot, or you may not familiar with that, but it is simple. So it just find out some like the agglomeration of that the data. For example, we are looking for the car accident hotspot, right? So then we got a data from somewhere, and then we run the hotspot analysis. Then it will show you like the location where the lots of car accidents in it. So we can directly find out like the physical places where the car accidents happens frequently. Also, we can find out like we can use some socioeconomic indicators such as like the higher education, low income, high income, or like the age groups, all different kind of like the data that we can find out some kind of like the clusters where they are concentrated on. So now, as you can see here, I got the Lakewood. This is the city of Lakewood, the blocks. Okay, so hotspot analysis we can do like with the polygon data. Also, we can do point data. But usually, I strongly recommend you use like the point data, because of course we can do like the hotspot analysis with the polygon data. So now we can hear like the point data and polygon data as well, right? So as you can see here, polygon data has all different size, right? So it makes some issues. Okay, so usually we can create like we can convert the polygon data into point data, then we start like the hotspot analysis. Okay, now there are several steps that you need to go. Okay, the first of all, so you need to measure the Moran's eye, which is called like the spatial autocorrelations. So the Moran's eye, which is as I said, like the spatial correlations. What is the Moran's eye? Okay, so I'm going to upload some of the PowerPoint that explain the Moran's eye. Okay, so you can look it up. So actually, Moran's eye is a correlation coefficient that measures the overall spatial autocorrelation of your data set. In other words, it measures how one object is similar to others surrounding it. If objects are attracted by each other, it means that the observations are not independent. So actually, this is the kind of the violation of the conventional statistical method. For example, like this. So you know OLS, like just the regressions, our normal regression analysis. Like it has like the one single linear combinations, right? That is the number one rule in the regression. It has to have one single linear combination. It does not accept like these patterns, right? So when we run the regression, we need to check whether or not this data set has autocorrelations. So this is the violation of the OLS. You should not have those kind of autocorrelation actually. So in the regression analysis, we actually remove this kind of the data from your data set. Then we can run the regression. Then you will create like this kind of the one single linear combination. Okay, this dot is the data distributions, and this dot also data distribution. But if your data set has the autocorrelations, that your data distribution is like this. It like here, then it has some other different pattern Okay, so this kind of pattern in the regression analysis, it does not, the, it is a violation. We cannot use like this. Okay, but spatial dependency, so autocorrelations, like we are thinking about like the spatial autocorrelation. So it's like the question is like, how do we know the degree to which one object is similar to other nearby objects? Okay, like here, like here, like here. Spatial correlation in GIS helps understand the degree to which one object is similar to other nearby objects. Okay, so the ArcMap provide the tool to measure the spatial autocorrelation. I know like you are not familiar with some like the statistical explanation, but don't worry about it. I mean, you can actually study a little bit later, but this time we can see the result, and then we can think about why this kind of like the hotspot analysis shows up. So we need to thinking about the story behind your like the hotspot map. Okay, so now here the first step to do hotspot analysis is you are going to go to measure the spatial autocorrelation. The tool located like here, system toolbox, spatial statistic tool here. Then if you go here, spatial autocorrelation Morenz-II. So you click this. Then you can see here. So input feature class. So I'm going to select the Lakewood point. Okay, so let me show you what kind of data I have. This is the block data. So I got a total population, young generation, low income, high income, like the high income job, white people, high education, and I got 2010, 2011, 12, 13, 14, 17 until here. Okay, so this is just my data, just an example. You are going to select your own data set. Okay, so I convert this the Lakewood the polygon file into the point, like the feature to point in the search box. Then you can see the tool. So then the input field, I'm going to select higher education 2017, and then you need to click the generate report. Then you will see like the report. It comes through like your web pages, and here I'm going to just use the default setting like this, like inverse distance, Euclidean distance, known, blah blah blah, and I click OK. And it pops up here. You click this, then you will see those kind of the result. Okay, so nothing, you need to see this index and those kind of like the z-score, p-value, those kind of stuff. And I'm going to click the report to file Morenz-II result and HTML. Click this, then it shows you like this. Okay, so Morenz-II index here, this one, this value, it should be in between -1 to, -1 to +1, in between that, but it should be positive. Okay, it should be positive. And here, if your data has like the Morenz-II spatial autocorrelation, you will have like this. If you don't have, it will highlight this or like here. So this is a dispersed, and this is a randomly distributed, and this is the clustered. So there is like the clusters, like the agglomerations, in it. Okay, so this is like the G score, means this is the statistically significant here, so this is okay. So you are going to report this global Morenz's AI here and these pictures. You need to capture this too and then insert your Word document. Okay, so then now we are okay. We confirmed there's like the clusters in it, so they spatially, I mean, blocks, some blocks, they spatially dependent each other. So we are going to like here, then can close this. So next step is we are going to go measure incremental spatial autocorrelations. So same thing here, input feature, I'm going to select the Lakewood point, and input field will be Higher Educated 2017, 10 neighborhood will be correct. You can use like the default setting. The problem is this point here. So the beginning distance, distance increment. So we do not know like the what distance we are going to start to measure like the incremental spatial autocorrelation by distance, right? So we do not know. So we need to know like the which distance we are going to start. So we want to know the beginning distance where I started counting from like how far away from any given points. So we begin looking, and then how far out do you want to go? Okay, so before we put this some number in here, we cannot just decide like that 100 or 200, something like this. We're gonna go here, go to utility on the spatial statistic tool, the utility, and then I'm going to click the calculate distance spans from the neighbor count. Okay, so we are going to select Lakewood point, and then I just click OK. Okay, then results pops up here, and then you click this. Then you can see here average distance, and this is in meter right now. Yes, in meter. So 109 meters. It means like the now what we did, we measured all the distance between the point. Okay, so we got 100, and then 0.1, 0.2, 0.1, 0.3, 0.1, 0.4, something like this, and then 0.2, 0.3, 0.2, 0.4. We measure everything. Then it create like the minimum distance and average distance and maximum distance. Now we got like the 109. Okay, so this is, you need to remember 109. So I'm going to set it here, average distance 100, I just say 100, and then I'm going to split 150. Then we're gonna start from 100 meters, then we are going to measure the spatial autocorrelation every 50 meters. Okay, so then now here, so row standardization, you do not need to use this, just use default. And then you are using this thing when you do when you use the polygon file. When you do the point file, you do not need to. So I'm going to click this folder, I'm going to save it. So I'm going to do incremental 1. Save it, then it will save the PDF file. Okay, so you're gonna click OK, then it's running. And it pops up here. Then it says like the first pick the 150, the second pick is the 300. This is one. If you click this, PDF file will pick, pops up, then you will see like this. Okay, this is the first like the peak, which is like the spatial autocorrelation is peak here. It's very strong, and this is the second. So you will see like here, you need to remember 300. Okay, 300 is important. Okay, so you are going to remember 300 here. Then I'm going to close it. So it's like here, this is like the by distance. I said like we start 100, like the average distance, then we split like every 50 meter. We are going to measure the spatial autocorrelation here. So it measures until 550 meters. So you can also convert these things into mile or like the feet or yards, whatever. Okay, this is a p-value 0.01. It's not significant. This is significant. This is significant. This. All these are significant. Okay, so yeah, you need to report this like the spatial autocorrelation by distance on your assignment too. Okay, so then I'm going to close this. Then you remember like the 300 meters. Then I'm going to click the spatial statistic tool and then mapping cluster. Then you're going to select hotspot analysis. Here we go. So then now what we are going to do, we are going to select Lakewood point, and the input field will be higher educations. Then I'm going to save this and like the point HEDU hotspot, and I'm going to click it. I'm going to save that one. So now here we hear the fixed distance. That's why we found max picks 300, this one. Okay, so we are going to put here 300. Okay, then we are not going to touch anything. We are going just going to leave it and then click OK. Then it pops up here like this. So let me click here, right? So now this is not really, it's not pretty. Okay, so then now what we are going to do, so this part is like this is a hotspot, 99%, like the confidence level here and here and here, not here. This is like the, then I'm going to go here. Then now we are here, interpolations. We click this, and then this is the IDW. So we are creating like the raster surface. Okay, so it will highlight the hot spot and like the cold spot, something like this. Okay, so now the input point feature, we click this, and then hotspot, right? And then G value field, you click this, and then here we have like the G score here, right? You click the G score. Then I will save this IDW HEDU 17 and click OK. And here you're gonna go the environmental settings like this, and then process extend, you click this, and then we are just going to select the same as the layer Lakewood, this one. Okay, also like the raster analysis, same thing, we are going to select Lakewood here, right? And click OK. So then now everything is default, then we are going to click OK. So then now it shows us like this, like the cold spot, something like this, but I'm going to change some settings, and then you go to right click this file and then go to property, and maybe I'm going to go like the sketches, and I'm going to looking for same as this, red and blue. Red and blue. I think this one, right? And also that here, and it's gonna be yes, like this. Apply and okay. Here we go. So this is same as this one. Okay, just look better, and then this is like the hotspot here, where like the higher education agglomeration is the these places, and then this is not there's no like the hotspot. This is cold spot, right? So this is the G score. Okay, this thing is G score. You can, whenever you want, you can change it. Okay, so this is the hotspot that we did. We statistically confirmed like it has the Moran's II, the positive Moran's II, and then we also select like the maximum peak distance for the spatial autocorrelations. Then the problem is behind this red and blue cold spot and hot spot. Why is that? What happening with this? So why it shows up like that this area is cold, and then me like I tried to make another stuff, which is like we got the Moran's II and then incremental. I'm going to do incremental again. I'm going to select the point file again. I'm going to select and higher education. Let's do like these higher education people are young people, or like they have high paying job here, and the high income people. And let me try like something opposite, like the opposite indicator, which is the low income. And then we can say the low income pretty much like the no higher education maybe. So I'm going to calculate. We did, right? We did. So it was, we used like the 100, and then we did like the 50 meters, right? Then yeah, I'm going to save it as incremental 2 because I want to see like the maximum peak. So spatial autocorrelation could be different, right? So the higher education spatial correlation and this low income, and I just click OK, and we are not going to use low. Here we go, we got 2 peaks here in terms of low income. I'm going to max 300 again here. 300, this is the max peak. So I'm going to do hotspot analysis here again, and I'm going to create the point, and input field will be low income. And I will do here, and I will say low. Click OK, we good. And maximum peak was 300, right? So everything is fine, and then I'm going to click OK. Then now going to click here. That's so interesting. So going to turn off this one, and here, so I'm going to do DIW, IDW, the low income, G-score, and ID2 low. Click OK, go to environmental setting and process, same as the layer of Lakewood and raster. Lakewood, click OK, and I click OK. Then I'm going to right click, properties, and symbologies, and stretch, and this one red and blue, right? This one, okay. Then I change the location and the Lakewood in the bottom, and I set up the slide here, and then I select 17 here, and I click this, and this is like the low income. Okay, the bottom is the higher education. So I do here, this is the higher educations, this is low income. That's interesting, right? So what we can see here, this area here, this area, like the pretty much low income, the lower education and higher, the lower income people and the higher education people live together here. Here we got like the strong low income, like the clusters in the middle of the city of Lakewood, and here, right? So then now we can thinking about why this kind of hotspot is distributed this way, right? We need to find out the reason. Maybe I can do some like the high income and low income. We can compare them. Like if the low income and high income hotspot, they overlap each other, then we can think, it is kind of like the gentrifying area. It's because like the high volume of like the high income people and high volume of the low income people, they stay together. But doesn't mean we need to think about those kind of things. Okay, so in your assignment, so you download, I mean, you also, of course you are going to have the instructions, so you are going to select your own data set, study area, and the indicator, the variable. Then you can do like the hotspot analysis like this, but you need to explain why you selected your data set and indicators for the purpose of the hotspot analysis. Okay, you need to explain that in your the assignment. Okay, so I don't worry, I'm going to give you the bunch of the instruction in it. So the technique is important, but the most important thing is after you create the hotspot analysis, then how you can interpret all this kind of phenomenon. Okay, so maybe this is really kind of a good tool for your final project. You may do some hotspot analysis, then you can explain more about your data set and like the expected like the happenings with this kind of data, right? You may need to do some literature review to explain this kind of phenomenon here. So it's gonna be interesting. Okay, So this is the hotspot analysis so far. So remember, we can do like the hotspot analysis with like the polygon, but usually the point is more accurate. So yeah, try to do like the hotspot analysis with the point file. Okay, so enjoy your assignment. Good luck, and if you have any question, then contact me. Thank you.